So I'm hoping you guys printed out this worksheet or at least wrote down the questions that I posted up on Google Classroom. It's a little easier to do it if you have the questions with me. And the first one says an angle theta in standard position and its terminal side passes through the point -3,5. Find cosine. All right, so what we're always going to do is we're always going to plot the point. So you're going to make an x and y axis, and we're going to go back 3, 1, 2, 3, 4, 5, up 5. That's your point. Now, in trigonometry, we need a triangle. So we're going to create a triangle using that point by coming out of the origin and going straight down. And there's my right angle. So the right angle always needs to touch the x-axis. And I'm going to put the theta right there. That's our corner. So we went back 3, up 5. Now what we're going to do is we need to find this missing side before we answer the question. So we're going to do Pythagorean theorem. So we're going to do 3 squared plus 5 squared equals c squared. So 9 plus 25, that's 34. So I get radical 34 equals c. So radical 34. All right, once you have all 3 sides set up, now we can go back. They want us to find cosine. Cosine, if you're thinking of SOHCAHTOA, right? Cosine is adjacent over hypotenuse. So if you're standing here, adjacent would be 3, and the hypotenuse would be radical 34. All right. Now, most of the time at your level, we don't like to leave radicals in the denominator. So we're going to rationalize it by multiplying top and bottom by radical 34. So I end up with 3 radical 34. Look at this quadrant, right? If I do A, S, T, C, this is the S quadrant. What does that mean cosine has to be? That means cosine is negative. And that's always the last thing you're going to check on. All right, so let's try the next one, number 2. An angle theta in standard position, right? We hit this point. 4, -7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So we're going to be here. So you plot your point. Then you're going to make a triangle. So the triangles always come out of the origin and to the x-axis. So the right angle always has to touch the x-axis. So we went forward 4, down 7. Then you're always going to do the Pythagorean theorem. 16 plus 49. This makes 65. I get radical 65 equals c. All right. Then you look to see what they want. They want sine. Sine is, now the corner is always theta. Sine is opposite, which would be 7, over the hypotenuse, which is the long diagonal there, right? Then we're going to fix it. So sine is going to be 7 radical 65 over 65. Now the last thing we check for, we do ASTC, right? ASTC. All right, this triangle is in the C quadrant, which means sine is negative. Okay, so let's take a look at this next one. You're given a point, and look, I want you to find all of them. So let's see here. 0.14, so I'm going over 1, up 1, 2, 3, 4. So here's the point. Draw your triangle, so you come out, and then you go to the x-axis. Okay, so I went over 1, up 1, plus 16. So I get radical 17. All right, and now they want us to go right down this list and find all of these. Well, sine, right here's your corner. Sine is opposite over hypotenuse. Now, what quadrant letter are we in? This is A, for all is positive. All right, then we're going to do cosine. Cosine is adjacent over hypotenuse. All right, tangent is OA, opposite over adjacent, which is 4. All right, now secant. Who is secant related to? Secant is the reciprocal of cosine. So all you have to do is take cosine and flip it over, so it'll be radical 17 over 1, which is radical 17. Cosecant is the reciprocal of sine, so I'm going to flip that over, which would be radical 17 over 4, and I'll put cotangent over here. Cotangent is going to be the reciprocal of tangent, which was 4 over 1. So that guy is going to be 1 over 4. And the reason why all of these are positive is because we're in the A quadrant. And there's one other thing we can do. Go back to these first two. Because these guys had radicals in the denominator, I'm going to fix them and give the best answer possible. So got that guy. And that guy. The rest of these are all fine because the radicals are in the numerator. All right. So what I'd like you guys to do is pause me and see if you could do 4 and 5 without me. All right, so I hope you pause me. -6. 1, 2, 3, 4, 5, 6, down 2. All right, so we went back 6, down 2. There's my corner. 6 squared plus 2 squared equals c squared. So it's 36 plus 4, which is 40. Now, radical 40 can be broken up into radical 4, radical 10. So that's going to be 2 radical 10. That's actually the best you could give me. Okay. Now, we want to find secant. Who is secant related to? Secant is related to cosine. So let's do cosine first. Cosine would be adjacent 6 over the hypotenuse, which is 2 radical 10. And then the 2 can pull off the 6 and make it a 3. Okay. This would be 3 over radical 10. So if that's cosine, secant is the reciprocal, means flip it over. So that'd be radical 10 over 3. Finally, last thing to check for. Look what quadrant we're in. What letter would be here? T for tangent. That means this answer has to be negative. So that's the answer for number 4. All right, so if you messed that one up really bad, again, pause me again and try to redo number 5. Okay, so I hope you pause me. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. This point would be here. And again, you always go to the x-axis. We'll talk about y another time. So 8 and 7 is beta. So I'm going to do 8 squared plus 7 squared. Okay, add these together and we get 113. So this is radical 113. Okay, which you can't break up. Okay, so now I want cosecant. Who is cosecant related to? Well, cosecant is related to sine. What would sine of this be? Well, sine would be opposite over hypotenuse. Okay. Cosecant is the reciprocal. Flip it upside down. Okay. And the last thing you check for, you do A, S, T, C. That's cosine. Was this cosine? Nope. so it has to be negative. And voila. All right.